Good morning. Today we're going to look at the electromagnetic spectrum, and I'll give you an overview of some main ideas with this new unit, and also we'll go over your 20 vocab words to give you an idea if you have good definitions or if you want to change a few, and that way you can understand the words a little better by the end of this video. So our question is, what is the electromagnetic spectrum? And at first, it seems overly complex, and you'll probably wonder, what is going on here? I have no idea what we're talking about when it comes to electromagnetic waves or radiation or ultraviolet. Relax. This is a topic that seems really hard at first, but as you get into it, you're going to realize this is all over the place. The electromagnetic spectrum is everywhere. Everywhere you look, something is using this. Or something is giving off light, or something's reflecting light or absorbing light. So today's goal is just to get the overall picture and look at your 20 vocab words. So watch the entire video if you want to get all 20 vocab words, my 5-word definitions, also explain some things and show some pictures. Here we go. First off, let's think about what is an electromagnetic wave. Electromagnetic waves transfer electric and magnetic energy from one place to another. So all of these waves, we can abbreviate them EM for electromagnetic. All of these waves transfer this electric and magnetic energy from one place to another. We better answer the question first. What is a wave? A wave is a disturbance that transfers energy from one place to another. Waves like ocean waves transfer energy from one place to another. Waves like Wi-Fi waves transfer energy from one place to another. Light waves transfer energy from one place to another. So it's all about energy, and it's all about transfer or motion, just like last unit. We're moving energy from one place to another. Remember energy? The ability to do work or cause change. And let's add something in parentheses here, to matter. So if energy is the ability to do work or cause change, and waves transfer energy from one place to another, I hope you can see the relationship here. And there's some overlap from our energy unit. I know that seems like a long time ago. Back when we were in school, and we weren't doing this remote learning thing, we talked about energy, remember? Different forms of energy, renewable energy. Hopefully you'll see how this topic on electromagnetic energy overlaps with what we've learned this year. Let's go back to matter. Remember matter? That was our second essential question in the year. Matter is anything with mass or volume. And mass is the amount of matter in an object. Or let's call it its matter number. We can kind of think of matter and mass as interchangeable, where matter is the stuff and mass is the number representing the stuff. Okay, so let's look back here. A wave is a disturbance that transfers energy. Energy is the ability to do work or cause change in matter. Matter and mass are these things that represent the stuff of the universe. And mass is just the number associated with that thing. All of this comes together in Einstein's famous equation, E equals mc squared. Energy is mass times the speed of light squared. The E is energy. The m is mass, which remember is matter's number. The c is light. And when you square c, you get E equals mc squared. We'll discuss this guy throughout because this energy and mass equivalence equation really makes this whole relationship between energy and matter and light make a little more sense. Okay, so there's the big picture. The electromagnetic spectrum involves energy transferred from one place to another. It involves waves, which are disturbances that transfer energy from one place to another. And what's affected usually is matter. Or sometimes these waves can travel through matter. Just like this prism picture here, glass changes the way light is refracted through that medium of matter that we call glass. All right, let's get into it. The electromagnetic spectrum, this was a picture from our last graph day. This, if you see, some of our vocab words are mentioned here, like radio waves, infrared waves, visible light, ultraviolet, X-rays, gamma rays. Notice microwaves is missing, but microwaves are really shorter radio waves a lot of times, but we're going to give them their own section on the electromagnetic spectrum. So all of these waves transfer energy from one place to another. Remember that definition. All right, let's look at our vocab. Bluetooth, here's what I came up with. Short range, wireless radio communication technology. So that's something that you use a lot, I'm sure. Bluetooth speaker, Bluetooth headphones, AirPods, whatever it is, uses Bluetooth technology. That's a short range radio communication. Color. Color is reflected light wavelength humans see. So the color of an object, whether it's that yellow at the top or that purple at the bottom, is the wavelength reflected off of that object. If you see a red apple, you're seeing those wavelengths from the spectrum reflected to your eyes. If you see something that is an orange carrot, for example, that part of the spectrum is being reflected to your eye. And color is part of that electromagnetic spectrum. If you look here, you'll see visible light, and all the colors we see are part of that spectrum. It's a small sliver, but it's part of it. Electromagnetic wave. Waves that don't require medium. An electromagnetic wave has a magnetic part to it and an electric part to it. So that together, electromagnetism has to do with both electricity and magnetism. Electromagnetic. Let's keep that in our brains. So anything that uses electricity, anything that's magnetic, has to do with this force called electromagnetism. In fact, anything that lights up has to do with this force called electromagnetism. And the waves that are given off are electromagnetic waves. They don't require a medium. A medium means something that a wave travels through. So a medium is a type of matter, like glass or water or air. Anything like that is a medium. These waves, electromagnetic waves, don't require a medium. So they can travel through empty space. Whereas sound waves require a medium. And sound can't travel through space because there's no matter in space. There's no medium for it to travel through. Another word we're going to look at is frequency. Frequency is the number of times wave passes. So if you look at a chart of a sound wave, it's the number of times that that wave passes past a certain point. Gamma rays, they're on the electromagnetic spectrum. Let's look back here. Gamma rays are all the way down here to the far right. These are shortest wavelengths. So they have the highest frequency. That means the waves pass by a certain point more. So EM means electromagnetic. We can abbreviate that with EM. EM waves, shortest wavelengths, highest frequency. Gamma rays are often associated with radiation. Infrared waves, EM waves between microwave plus light. or microwaves and light. Your remote control oftentimes uses infrared waves. You'll see the little bulb that emits some kind of radiation. It's not radiation that causes cancer or anything like that. Don't confuse that. When we say radiation, that just means some type of electromagnetic energy given off. And if your younger brother or sister stands in the way of that remote, you can't change the channel, right? Because that infrared wave is being blocked. And it's a harmless infrared wave, but that's how it transfers energy from one place to another. So when you press channel 1, 2, 3, you are giving this remote the information to transfer that energy and talk to the TV, and you can change the channel. Laser, device that produces coherent light. So a laser can be dangerous, right? Lasers can do damage to our eyes. Lasers can do damage to matter. It's coherent light, and we'll look at lasers in this unit. Light. This definition might be a little tricky, but I came up with EM waves humans can see. So when we talk about light, I'll usually say visible light, but light itself in this kind of definition is, when things light up. So these are the waves that we can see. Our eyes are visible wave detectors. We can see light because our eyes can see those reflections. When you turn off the lights in your house, there's no more reflection, is there? It's harder to see because there's less light reflected. Mechanical waves. Mechanical wave is a wave that requires a medium. Remember, we talked about medium. A medium is matter. So water here is the medium. And when this person causes a disturbance in the water, it causes a ripple across the water surface, and those are waves. They're disturbances that transfer energy. Not much energy, but enough. Microwave. Microwaves are EM waves between radio and infrared. When you are cooking or heating something up in the microwave, you are actually using a form of light, a form of electromagnetic radiation. Once again, this doesn't mean that it causes cancer or that it, is poisonous or something. A microwave just is tuned in to hit water molecules, and it makes those water molecules move faster. And when those water molecules move faster, what do you think happens to the temperature? It goes up. So if something has water in it, then you put it in the microwave, it makes the water molecules move faster, and then it gets hotter. A photon is a particle representing light energy packet. This is a hard definition to think about and even a harder picture to find. But a photon is basically a light particle, and light can act as both a particle and a wave. And a photon is this smallest particle that somehow we don't completely understand it, but it transfers energy, and light can act as a particle, and when it does, we call it a photon. Radar. System detects reflected radio waves. Radar works because it's detecting things by shooting radio waves out there. And when the radio waves bounce back, we can see something's there. So just like your kid brother or sister standing in front of you with the infrared remote control, we shoot out radio waves, which is a different type of radiation from the electromagnetic spectrum, and it bounces off that object, and then we know something's there. Radiation, energy transferred by electromagnetic waves. So this definition of radiation is a bigger definition than the one we use in everyday language, which might mean something that comes from a nuclear bomb or something that's radioactive. Radiation is just energy transferred by electromagnetic waves. I don't care if it's radio waves, microwaves, visible light. A light bulb radiates visible light. It also radiates infrared. Radio waves, electromagnetic waves, longest wavelengths, lowest frequency. So let's go back to that electromagnetic spectrum here. Radio waves are here on the far left side. They're the longest wavelengths and the lowest frequency. Remember, frequency is the number of times that this wave passes by a certain point. So you see how these waves pass by a certain point very quickly. These waves pass by a certain point slower. So radio waves, the longest wavelength and the lowest frequency. A thermogram is an interesting scientific technology. This image shows temperature as color. This line here, you can see the darker the colors represented in a thermogram, the cooler the part of the object. The lighter the color, look at the eyes and the ears. This white, yellow color, the hotter the temperature, the higher the temperature. So a therm, remember, means something to do with heat or thermal energy. This right here is a thermogram. Ultraviolet rays, or we could call them UV rays, EM waves between light and X-rays. So ultraviolet means beyond violet. So you get to violet on the light spectrum or purple, and you go beyond violet and you get ultraviolet. This picture here shows different images of a flower. This one on the top left is how the flower looks in visible light. Over here is a different part of the UV spectrum. So when you take an image with UV light, you can see these different things. The interesting thing is bees and insects can see, we believe, in UV light. So they not only see in part of the visible light spectrum, they can also see in this spectrum that we can't see, which is called ultraviolet. And let's go back to our radio or our electromagnetic spectrum. We have red, orange, yellow, green, blue, indigo, violet. Then beyond violet, we have ultraviolet. If we go this way, violet, indigo, blue, green, yellow, orange, red. Below red is infrared. That's what infra means. So infrared to red to orange, yellow, green, blue, indigo, violet, and then after violet is ultraviolet. A wave in general is a disturbance that transfers energy. So that can be an ocean wave, something that you think of. It's a disturbance that transfers energy from one place to another. Wavelength is the distance between crests of waves. So a crest on a wave is the top. Here's the crest. From one crest to another, we call the wavelength. The bottom of the wave is called the trough. And from the trough to the crest is the amplitude. So the amplitude is from the trough to the crest. But we're concerned here mainly with wavelength. Remember, the longer wavelengths are radio and microwaves. The shorter wavelengths are X-rays and gamma rays. Wi-Fi. Wi-Fi stands for wireless fidelity, if you ever wonder that. Wireless fidelity using radio connection. So a Wi-Fi signal is a back and forth energy transfer. It's on the radio wave part of the electromagnetic spectrum, and it's transferring energy from one place to another. So you can stream Netflix or YouTube or watch this video here. Finally, X-rays. X-rays were discovered by Wilhelm Röntgen, and he didn't know what they were, so he called them X-rays, like a variable in algebra. And the name has continued here. So X-rays are electromagnetic waves between UV and gamma. So they're on that higher energy, higher frequency side of the electromagnetic spectrum. And this is the first X-ray that Röntgen took of his wife's hand. You could see his wife's wedding ring, and Röntgen wins the first Nobel Prize for his discovery of X-rays. And we'll see how X-rays change humanity, because we can actually see inside the body. And, if you have an injury, you can see inside, and you can see what's happening without having to do surgery right away. So that takes us to the end. I know this has kind of been a longer video, but I wanted to help you out with these vocab words. Make sure you pause the video, go back to the video. I'll share these notes on Classroom so you can see these. And today's lesson is all about just getting this big picture. What is the electromagnetic spectrum? I know I threw a lot of information at you today, but stick with it. Okay, find some good images for those 20 vocab words. Think about what those vocab words mean. Look around your house, see these things that we're talking about with electromagnetic energy. And tomorrow, we'll go back outside. I'll have Charlie and Everett, Noah, and Jamie help me out with some videos that we can do about the electromagnetic spectrum. All right. I hope you're doing all right out there. I miss teaching you guys. Hope you're doing well, and take care.